I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
Hi, and welcome back. We're back on part 2 of the Hammond Jr. Video series, where we try to bring this Hammond clock back to life. And one thing I hinted at toward the end of the last video was there was something I was missing, and I have discovered since, about the clock and the case. And I was asking if you had figured it out yet. As you'll recall, the clock went into the hideous wooden enclosure, as my daughter and I call it now, like that, with the front facing out. And then this piece of plastic went, let's see if I can, it was covering the back, like that. Thusly, and exposing all the controls. Well, I figured out finally that there is something odd about this, and that is that this opening to control the brightness of the light was actually broken out. It wasn't cut out, it wasn't manufactured that way. It was just broken out. They just broke a wedge of bakelite out of there. And then I finally realized that this was on backwards. What they did at the clock factory is sold this unit with the bezel in there and the glass in place, like that. And then the clock movement sat in here like this. And that is a complete clock. I've got that in there cattywampus, but that's okay. The part they broke out at that rustic factory would cover the light bulb, and the light bulb would light the dial face from the back. So this is actually a complete clock. It has a couple of problems. One is that, set this aside again, or the case has a couple of problems, I should say. Severe problems. One is that this broken out chunk, and this chunk here, they drilled a hole through the bakelite to bring the cord out the back. So they reused this. Bless them for doing that. But what a strange idea. You get a clock from Hammond, you take the case off, you build a wooden box, you put the clock in the box, cutting a hole for the bezel and everything, and then you just turn the case around and put it on the back. What an idea. Yep, that rustic company did things in a pretty rustic fashion, I must say. So that's one problem. We have a case that has a damage in the front and a hole here, which is also damage. Also has a crack right there, missing material. My inclination is to go ahead and repair those. Bakelite's pretty amenable to JB Weld, the steel reinforced epoxy. And so what I'll do is I'll smooth this edge and try to grind a little divot along here. And anyway, backfill this with epoxy. The epoxy is gray. This is bakelite brown, so that won't match very well. I'll do the same thing here. I'll try to recreate this using epoxy and fill that hole using epoxy. And what we'll end up with, if I do a good job, is a case that's been structurally put back to where it should be, but will not show the Bakelite because it will then have to be painted. So this will be not amongst the first Bakelite painted cases. I'll try to recreate this mahogany looking swirly Bakelite. This is so dirty you can't really see the texture in it, but Bakelite is really quite lovely stuff. But this will be painted, so that'll be fixed. So the next part is to talk about the clock movement itself. And before we get too far into that, I want to talk a little bit about the guy who invented this clock. His name was Lawrence Hammond, born in 1895 in Evanston, Illinois. Had an interesting childhood. His father died, and so his mother moved the family to Europe in 1897. And in 1907, at the age of 12, Lawrence filed his first patent declaration with France for an automatic gear shift for automobiles. I think the story goes he took it to, who was it, Delahaye? I can't remember. One of the early French automotive manufacturers, and presented his idea. They told him it was an interesting idea, but that it would take some materials that there was no way that it would require some material that was unobtainium in those days. They returned to the United States in 1909. 1912, young Mr. Hammond filed for a patent for a mercury barometer, which got approved. Went to Cornell and graduated in 1916. In 1928, patented the synchronous motor that's used in this clock. And a synchronous motor is a motor that doesn't depend on a pendulum or any escapement to keep time. It depends on the frequency of the AC coming from the power company. So in this case, this clock depends on 60 cycles. As long as the power company keeps 60 cycles running into this clock will keep very accurate time. It's not much unlike the Techron clock invented by Henry Warren. The biggest difference between the Warren synchronous clock and the Hammond synchronous clock, and maybe the only reason that Hammond could get a patent on this clock, was Warren's Telecron was self-starting. This clock is not self-starting. I don't think any of the Telecrons were, or the Hammond movements were self-starting. Some of them did have a spring wind-up thing so that the power went off, it would keep going for a while. And then if power came on before the spring wound down, that would bring it back to life. This one, however, if the power goes off, you have to restart it. And all of them start with a little, this one has a wheel right here, and you spin this wheel, and that restarts the clock. So if it's been unplugged, plug it in, give this a spin, counterclockwise, it says right there, and away it goes. You can set time, you can have be silent, or you can set an alarm with this one. Here's the alarm setter, time setter, and down here, as I said, is the light that that glows right here. Well, Hammond clocks were great. Hammond could sell licenses for these things like crazy, which he did do in the late 20s and into the early 30s, when it was discovered that, in fact, the first electric synchronous clock was probably made in Germany in the late 1800s. And so his patent was withdrawn. Fell through, had to give, I don't know if he had to give back any of the patent fees, the licensing fees that he made, but the Hammond Clock Company was destined for the dust pile. So Hammond got really busy, and he invented another product that would keep the Hammond company going for a very long time, and that was the Hammond organ, the famous Hammond organ, patented in 1934 by Lawrence Hammond. By 1941, they stopped making clocks. They couldn't make any money because they didn't own the patent, so they just got out of the business. So here's a clock company that lasted about 20 years. Made a lot of clocks. There are a lot of Hammonds out there. Two varieties, and we'll talk about that in a little bit. Two varieties of motor. One is an open motor, where the coil and the mechanism that it drives are open inside of here. The other is closed, sealed mechanism, sealed rotor, which is very much like the Telechron, except again, this clock will not start by itself. The Telechron could self-start. So let's see if this clock has a chance of working. My daughter said when she got it, she plugged it in, the light glowed, but the clock didn't run. Well, electric clocks are kind of like old radios. You really don't want to plug them in without checking out a few things. A clock is easy to check out because all electric clocks that run off the wall power have a coil right here. So there's a coil, and I'll talk more about how that works in another video. But there's a coil right here, and that coil is just connected across these two wires, which are the outlet. So if that coil is good, if there's continuity in the coil, and remember a coil is just a piece of very fine wire, in this case wrapped many times around a form, and but it's still copper wire, it still conducts electricity. If the coil is good, what the clock should have is continuity. It should have some ohmage, some measurable ohms right across the power line right here. Of course, it's not plugged in. I cut the power cord off because it needs to be replaced anyway. But if this coil is good, then the clock has a chance of being restored. If the coil is not, it still has a chance, but it's a much slimmer chance, because those coils are, well, you could make a new one, I suppose, but I'm not gonna. So let's see if we get some DC resistance across this outlet. Let's see, can you see that? Glare there. So we should have something, I would guess, somewhere between 50 and 250 ohms DC resistance right across there. So here we go. And there it is. 0.61K, 61 ohms, 61.9 ohms. Or no, 618 ohms. That's fine. That's good. That's very good. That means the coil is intact and the clock is restorable, probably. Now I got to confess I'm not an horologist, one who works on clocks. I only know about them what I see in front of me and what good videos that there are available on YouTube. So I have referenced some of those already just to see what I'm up against. And I also bought a book. I like books. And this is the one and only go-to guide for Hammond books. Hammond Synchronous Clocks, Maintenance and Repair by Craig Shields. And Craig has done a good job in here of talking about, toward the back he talks about patents and various cases. And in the middle he talks, well, starting at the beginning, actually he talks about, almost jumps into how to restore them. So here's a chapter. Chapter 2 starts with open rotor clock disassembly postal telegraph. And this, in fact, is very close to the movement that you see before us. But I think there's another chapter in here with another movement that's even closer. But it does talk about the open rotor motor that we have here. So anyway, I'm going to be referring to this a lot. And if you want to work on Hammond clocks, you should get one of these as well. All right, short video this time. What I will do is study up on how to take this apart. I've got to start by taking the hands off and the dial plate. I don't want to damage the hands or the dial plate in this process. So the next video will be disassembly of that, and we'll look at how the case, the housing comes apart at that same time. So should be an interesting little project. We'll see. And hopefully this will go back in this, and this will be repaired by the time we're all done. All right, see you next time.